Tutorial sheet. This is sheet what? Sheet 9. Sketch a following curve by finding. So you sketch indicating or intercepts maxima and minima and point of inflection. A y is equal to x power 3 minus 9x. Minus 9x. So the first thing that you do to get the intercepts, you equate this guy to 0 to get the x-intercept. So you factor out x, you have x squared minus 9 is equal to 0. So we have x is 0. We also have x is plus or minus 3. So when we are sketching, so far, the question is about sketch, so you must be quick to sketch. So far we have -3, we have 0, we have +3 as the intercepts. We're now looking for the other intercept is the y-intercept. When x is 0, we get 0. So that is the y-intercept there. We also have this guy as an intercept. Then we find the maximum and turning points of this. So now we're in calculus. Remember, when you're dealing polynomials, we are taught when you do calculus, you know the turning points. Now this is calculus. So what are the turning points? So you differentiate this, you get the first derivative, which is 3x squared minus 9, and equate it to 0. So solve y prime is equal to 0. That is 3x squared minus 9 is equal to 0. So get x squared is equal to 9 over 3. So x is equal to plus or minus root of 3. So negative root 3 and positive root 3 will give us the turning points. What nature? Now we only have the x coordinates. A point has x and y coordinates. So we get these x, take them in the original function. So y, what is y when x is positive root 3? So we have this to the power 3 minus 9 root 3. So we'll get 9, we'll get 9 root 3. This is root 3, we get 3 root 3 minus 9 root 3, which is equal to -6 root 3. So here we have -6 root 3, a point. And then when x is root 3, we'll have, so it's like I've put it on the negative. So it's on the right. -6 root 3. So what happens when x is equal to negative root 3? We'll have this to the power 3 minus 9 minus root 3. So we'll get -3 root 3 plus 9 root 3, giving us 6. root 3. So we also have 6 root 3. So we have a point there. So we have 2 turning points. Of that nature. So now we can sketch. I think everything is known. Or if you are not so sure, you can also get the second derivative. So from here, we get the second derivative. So y prime prime is going to be 6x. And then substitute each of these points. The one that gives us, for example, we substitute negative root 3, we would get 6 root 3 negative. Meaning that the one that gives us a negative is a maximum. And the one that gives us second derivative as a positive is the minimum. So they do the opposite. So now we sketch. So it look like that. That is the graph. The graph also says find the point of inflection. So the point of inflection you get the second derivative y prime prime, which is equal to 6x, and equate it to 0. So x is 0. Then you can substitute in the original function 0 where there's x. So the point is going to be 0, 0 is the point of inflection. Questions, if there are any? Vanessa?
No, sir, I'm clear.
Eugenia?
I'm clear, sir.
And Michelle?
It's clear. Sir, I have a question first. It's not on this, but it's just a question that when you're differentiating, for example, open bracket x to the power 4, maybe minus 2 to the power 3. How do you differentiate that? Do you bring the power 3 to the front and then continue expanding it, or you expand it as individual? You expand it as x to the power 4 minus 2, another x to the power 4 minus 2, and another x to the power 4 minus 2, or you bring the 3 in front?
No, you just
do the bracket.
So if this was y, this would be a derivative.
Okay.
And if we wish to expand, we just say 3 times 4, 12, x power 3, x4 minus 2 squared, and leave it here.
Okay, thank you.
So let's go to the second one, B. We want to sketch y is equal to x4 minus 6x squared. So first thing, we find the x-intercept. So we equate this to 0. So we have x squared minus 6 is equal to 0. So x is equal to 0, or x is equal to plus or minus root 6. So we can start our sketch. Already we know it will cross at root 6, negative at 0, and at positive root 6. The y-intercept, of course, is 0. Then the turning points. So we differentiate. We get 4x power 3 minus 12x, and equate this guy to 0. So we get 4x, x squared minus 3 is equal to 0. So we have x is 0 as a turning point. Also, x is plus or minus root 3 as turning points. So negative root 3, this guy here, and also positive root 3. These will give us turning points when we take them back in the original question. So what is the original equation? So when we take 0, we'll get 0. That's not a big deal. So let's take negative root 3. Negative root 3 power 4 minus 6 negative root 3 squared. Now root 3 power 4 is 9. Root 3 squared is 3. Then 3 by 6 is 18. We're getting negative 9. So this guy is giving us negative 9. So we have a point here. And then the other one will also give us negative 9 because the powers are even. So, okay. We are substituting again positive root 3 to the power 4 minus 6 root 3 squared. So we'll get negative 9 again because the first one is 9. Hello?
Janet is failing to join. I don't know if you can resend the link for her.
Okay.
So I've got a question before you go further.
Okay.
Here where we're finding the value of y, since we used 3 plus or minus root 3, is it always that you use the value of the second derivative, or okay, why didn't you use 6 instead of 3?
Okay. So these are the x-intercepts. The ones we equate the original equation direct to 0. The one we use to find the turning points are these where we equate the first derivative to 0. So we have also used 0. When you substitute, we get 0. So that's why we also have that point here, this point here, and that point here. So we have 3 turning points.
Thank you.
Okay. So if you want to know If you want to know, if you wish to check the nature of your points, in case you're confused on how to sketch it, you get the second derivative. That is 12x squared minus 12. You substitute 0 here, we'll get negative 12, indicating that that point there is a maximum point. And it can only be maximum if the graph comes this way. That is our graph. So now we know the turning points. What about the point of inflection? You equate the second derivative to 0. So point of inflection, you equate this guy to 0. So 12x squared minus 12 is equal to 0. We get x squared is equal to 1. So x is plus or minus 1. Substitute in the original equation to get a full point. So we'll get 1 minus 6, which is equal to negative 5 for both. So the points will be plus or minus 1, negative 5.
Sir,
Hello.
sir, I've got a question.
Uh-huh.
Now, sir, where is the 12 gone? Since this other 12 here is a constant, yes, we know it's become 0. And then, so meaning we're going to remain with 12x squared. Now, where is the 12 gone?
No. That other 12, a constant, does not become 0. This is our derivative, actually. What is the second derivative? We are together. This is the second derivative, is it?
Yes, sir.
Now we are equating this same thing to 0.
So meaning we're not differentiating.
No, we have already differentiated. We equate the second derivative to 0.
Okay.
So we take 12 the other side and divide by 12 to have x squared is equal to 1.
Oh, it's too simple to my steps.
Now let's do see so that we make it detailed so that Janet also can catch up. See, we want to sketch y is equal to x power 5 minus 5x power 4. So step 1, solve for x intercepts. Okay, you equate y to 0. So solve y is equal to 0, which is x 5 minus 5x power 4 is equal to 0. This one is giving us x power 4 factored out, and then x minus 5 is equal to 0. So we have x is 0 or x is 5. We can even start sketching now. So we only have two intercepts, 0 and 5. Second step, step 2, y-intercept. In the function where there is x, you take 0. We'll get 0. So we have this 0, 0 here. Is also a y-intercept, which is true. Third, maximum or minima. So what do we do? Find the first derivative. And equate it to 0. So we find y prime, which is 5x4 minus 20x3. Then we equate it to 0. Minus 20x3 is equal to 0, giving us x3, 5x minus 20 is equal to 0. So x is 0 and x is equal to 4. So we have the turning point. 0 is a turning point, and at 4 we have another turning point. So we get 4 now. So we can say step 4, substitute the x coordinate obtained in step 3 in the original equation. So we substitute when x is 0, we get 0. So that is that turning point here. When x is 4, we get 4 to the power 5. Okay. Minus 5, 4 power 4. So here we'll solve it mathematically. We'll factor out 4 power 4 and remain with 1 minus, and remain with 4. We'll remain with 4 minus 5, which is equal to 4 power 4, that is 16 by 16. What is 16 by 16? 36 under 3. So 9, 0, 6, 1, 6, 15, 256. So it will be negative 256. So we get negative 256. Another point here. Well, so we can sketch our graph. So far, it can be sketched in this form, or we can wait a bit and get the point of inflection. The inflection point, you differentiate this guy again. So step 5, differentiate. So let's just say find y prime prime and equate it to 0. to obtain inflection points. So what is y prime prime? Well, first we get y prime. Y prime is equal to 5x4 minus 20x3. 5x4 minus 20x3. Then we differentiate this guy. It will be 20x3 minus 60x squared. Then we equate it to 0. So factor out x squared will remain with 20x minus 60. So x is 0 is the point of inflection, and also x is equal to 3. Another inflection. So for 0, we already know the coordinate of y, but for 3, we have to substitute. So y is equal to, we're now dealing with the original again, x5 minus 5x4. So x5 minus 5x4. So when x is equal to 3, we get 3, 5 minus 5, 3, 4. So we factor out 3, 4, we remain with 3 minus 5. But 3, 4 is 9 by 9, which is 81, multiplied by negative 2. So we get 162 negative. So we have 3, 162 negative, 3, negative 162. This guy here is an inflection point. So we sketch. So our sketch will go this way. Hammer there, come down. It must delay a bit. If we are able to show, must delay a bit there, but proceed to the turning point and go like that. I can draw this well, starting from there. It's a graph of this nature. Do we have questions? At least now it's detailed, is it? So the points of inflection are 0, 0 and 3, negative 162. These are points of inflection. That's how it comes out. We log out and quickly log back so that we can do some more.